Okay, well, let's quickly do a checklist. Adrenergic system started? Yes. Synthesis of catecholamines done? Of course. Storage of catecholamines done? Yes. Release of catecholamines done? Yups. Reuptake of catecholamines? Nopes. Metabolism of catecholamines? No. So what's le sujet du jour d'aujourd'hui? I mean, what is the topic of the day? Well, it's a sequel of last episode. That is, it comprises of topics like reuptake and the metabolism of catecholamines, and much more added only if the clock allows. Let's go. Welcome all to his Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Now, it should be well understood that whatever catecholamines, be it adrenaline, be it noradrenaline or dopamine, when they are released in the synapse or the terminus of the nerve, all are taken up back, and that too in a proper stepwise method. What are these steps? Let's get to know them. The first step is the uptake at the axon level. Membrane of the nerve or the neuron, it presents active amine pumps. These are capital NET, which via the sodium coupling, they do the work of the transporter of noradrenaline. Now, this is defined as the uptake 1 process. And what are its features? It's of higher rate for the noradrenaline than adrenaline. The pump is actually not a specific one. That should be very well noted down, as it is seen to have uptake of few indirectly acting sympathomimetic amines like amphetamine, etc., but not isoprenally, that is for sure. So once the uptake occurs, it's a sign of the end of the action and the effect of noradrenaline in the synapse and also the further sites. Can you imagine? Around more than half of noradrenaline is taken up back. And it's very nice thing to know that the blocker of this capital NET pump is also there. And one of the good names to know is cocaine. Yes, cocaine blocks the capital NET pump. That was all about the first step. Let's move on to step number 2. Next in discussion viewpoint is the uptake at the vesicle level. Capital VMAT2 pump is presented on the vesicular membrane. It does the job of transfer of catecholamines from the cytoplasm to the vesicle inside, where these catecholamines are actually stored. Now, this transfer is in the exchange of the hydrogen ions. Noradrenaline released from the vesicles is also reuptaken, and dopamine is also reuptaken. All these processes, what is the purpose of these processes? Well, they balance the noradrenaline amount well enough. If you want to know the name of the blocker of this uptake mechanism, it's a well-known name, reserpine, which works to block this uptake and also decrease the catecholamine content of the neuron. So, what did we get to know? Capital NET and capital VMAT2, they operate at the neuronal levels. While there are some transporters which also operate apart from the neuronal sites, and some of the well-known names to account for are the capital OCT series and the extraneuronal amine transporters, which are abbreviated as capital ENT. I really hope and I'm sure that you currently remember the uptake one. Yes, that was of noradrenaline, whose rate was much higher as compared to adrenaline. So why am I repeating or why am I revising this particular thing? Because, well, the uptake by the capital OCT series and the capital ENT group of neurons is known as the uptake 2. And how is it different from uptake 1? In uptake 2, the rate of adrenaline uptake is much higher than the uptake of noradrenaline. And now you should know what is the blocker of this uptake 2. It is corticosterone. So that was a good description all about the reuptake of catecholamines. What's our second part of today's discussion? Let's talk about the way catecholamines are metabolized. Now before I proceed, it should be crystal clear that the metabolism of catecholamines is not the major terminating route of the action or the effect of catecholamines. Yes, it is not. Now what are the enzymes involved? Capital MAO, monoamine oxidase, and capital COMT, catecholamine O methyltransferase. These are the enzymes that metabolize the noradrenaline outside the neurons and also in the liver, respectively. I mean to say, the capital MAO is working outside the neuron, while capital COMT is actually having its effect inside the liver. Now, in the whole process, what is formed? Vinyl mandelic acid, that is capital VMA, is formed. The process of metabolism is majorly done via this route, while minute routes, they include the enzymatic function of aldehyde reductase, that is capital AR, aldehyde dehydrogenase, that is capital AD, and also alcohol dehydrogenase, that is capital ADH. All in all, what you need to know is the capital VMA, that is vinyl mandelic acid, is majorly excreted in urine along with the small quantities of some of the petty metabolites like metanephrine, norepinephrine, etc. Two more processes you need to know is conjugation by glucronidation and sulfation. They occur prior to the urinary excretion. So these were the most important points or a brief description, a kind of a small tete-a-tete all about the reuptake and the metabolism. Now we can say that termination of action of catecholamines in nutshell. Right? Well, it's a combination of both the processes, reuptake and metabolism. That is the termination of action of catecholamines in nutshell. Many more little conversations await this month's duration. So what you have to do is simply stay tuned for more of these. Till then, I'll be Anto. For all the updates and latest episodes of my podcast, do visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you're listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.